Hi, 8.3. So in 8.1, we talked about this. In 8.2, we added on this. And now we are going to add this into our equation here. So 8.3, we're going to be talking about how to graph a quadratic equation in standard form, ax squared plus bx plus c. And we're going to find the maximum and minimum values of that quadratic equation. So I talked briefly what max and min were in the previous two lessons, but I did go into it or how to find it. So notice our graph isn't centered now on the y-axis. It's not centered right here where it just goes up here and here. It's no longer centered there. It can be centered anywhere. So when I have a function and I'm looking for where is my vertex, I get to use this quick little formula right here. And the axis of symmetry, believe it or not, is exactly the same, which I know you would believe because we've done it. So you're using the B and the A, and you're just using that formula, including that negative right there. So when you're taking a look at maximum and minimum values, which is which? Well, if you take a look at the two examples right here, maximum means this is the highest the graph goes. That is your maximum value, the highest it can possibly go. And minimum means this is the lowest the graph goes. So it's also your vertex. Kind of handy, right? So you have your vertex and your max and min. So if I'm looking at an equation and I'm trying to figure out what that is, I'm just going to use that formula that I just talked about a minute ago. So I'm going to zoom in here for a sec. And the formula that I'm using is basically, I'm going to rewrite it right up here. Here, I'll move this down a little so that you can see it. So you can see where I'm getting these numbers from. It is negative b over 2a. Oops, still can't see it. Okay, there we go. Negative b over 2a. So ax squared plus bx plus c. So this is the two numbers I'm going to use. Remember, if there's nothing in front of us, it's a 1. So it's negative 10. I'm just using an x for my axis of symmetry because that's for the axis of symmetry, which is going to be the same as where my vertex is, but I'm going to have to do more work to find that. So this is negative 10 over 2 times 1. And remember that this is negative. So this is 2 times 1 is 5, right? So you have a negative and a negative, or sorry, 2 times 1 is 2, divided into negative 10 is negative 5. Negative 5 times negative 1 is 5. So my axis of symmetry is where x would equal 5. So it'd be like over here in a graph, right? If that was a 5. That would be my axis of symmetry. Done. Now, to find my vertex, I have my x point. I know it's somewhere along this line, but I don't know where. So I just need to plug it in here to figure out what that value is. So f of 5 is equal to 5 squared minus 10 times 5 plus 2, or negative 23. So my vertex is, sorry, I had to move a cat. My vertex is 5, negative 23. So it's way down here. And then the graph from here, because this value is positive, would go up. Okay, let's try this again. Hopefully after a couple of times you'll get it. And it'll completely make sense to you. I know the first time you see it, it's going to be like, what the what? What is she doing? All right, so notice I don't have a C here. So remember, if you don't have a C, it's like having a 0, and that's completely fine. We just don't bother to write those kinds of things because what's the point? So there's two ways you can actually do this one. We're going to use this way because that's what we're actually learning right now. Then I'm going to kind of allude you to how you could actually do this a little differently. So if you did this problem, you'd be looking at negative 16 over 2 times negative 4. So that equals 2 when you get done with all that. So your axis of symmetry x equals 2. Okay. So I want to figure out, that's my x value, but I want to figure out what happens when I plug that in here and get my y value. So I have -4 times 2 times 2 plus 16 times 2, and I get 16. So my vertex is at 2, 16. So if I was looking at a graph, it would be like, here's my 2, it's way up here. The other way you could possibly have done this, if you're just, well, no, that actually, I'm sorry, you can't do it a different way. That would be if you're looking for zeros. Not looking for zeros, just looking for vertex and symmetry here. Sorry, I know I told you to be another way, but there it is, but it's if I'm looking for zeros. Okay, so next problem. Let's try it again. The more you do this, the better you get at it. So I'm going to write that -b over 2a, -b over 2a. I'm going to write that right there so that you guys can see it, because I can zoom in better that way. So here's your b, so -6 and over 2 times -3. So when you get done with all that, you get 1. And so your axis of symmetry, x equals 1. And if I plug this in, I get -3 times 1 squared plus 6 times 1 plus 1. I get 4. So my vertex is 1, 4. Don't you love math? So much fun. Okay, so last one of these, and then we'll flip to the back side and do some more. So you have -8 over 2 times -2, and then all that is negative. So by the time you get done with all that, you end up with -2, because this negative and this negative would make it positive, which would come out negative. So axis of symmetry, x equals -2. Forgot an equal sign there. Okay, so when I plug that in, so I get -2 times -2 squared minus 8 times -2 plus 5. So I end up with 13. My vertex is -2, 13. Forgot to write vertex. And that's basically your start of your graph. Okay. Now I'm just going to go back through these real quick, and I know it's not asking me to, but I'm going to go back through them real quick, and I'm going to show you how you can determine whether you have a maximum or a minimum on these, because we're going to be doing some of that on the back side. So if I just run through these real quick, and you'll actually get to see how that works. So this is positive. So this is a minimum. This is negative. So this is a maximum. Okay, that means the graph is going down. And this is negative, maximum, and negative, maximum. Okay, we're going to do more of those on the back side. I just wanted to throw that in there so you could see where I'm getting, how you're going to know it's a max or a min. All right, let's do some graphing. So these are a little difficult because you don't have the idea where you might be putting this. So when I did this graph, just if you want to take a second and follow along with me, I did it here, and then I did it here, and I did this one here, and then I did it here, and then the last one, I did it here, and here again. So it's like the first one. And I made these my axis, okay? So that you can actually see where your axes are. So a couple of things. Notice this is going to be positive. And notice that I have a y-intercept of 2. So what does that mean? This is my y-intercept right here. Y-intercept right here. Okay, so I know the graph's going to go through there, but I don't know where it's going to be here. It could be all the way down here. It could be right over here. It could be really wide. I don't know. Well, I actually know it's not going to be super wide, but I want to figure out where that's at. So I'm going to do my negative b over 2a. Let me zoom out a little. Negative b over 2a. And so when I do that, I actually get negative 6 over 2 times 3, which is negative 1. And I know that that is where my vertex is. So at negative 1, if I plug a negative 1 in here, I get negative 1. And so from that point, I know that everything else is going to be symmetric. So if you take a look at the numbers that I put here, this is my vertex. Everything after that is symmetric. So if I was to go to negative 3, that would be the answer would be 11. If I was to go to negative 4, I'd have to plug that in, but I could get that answer. So if you're graphing this, you get negative 2, 2, negative 1, negative 1, and 1. I don't think I'm going to get to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's way up here. So you can see the graph is pretty thin or stretched. See if I can zoom out a little more. There you go. So just some of the attributes of the graph. Again, this is 2. This is where your y-intercept is. You found your vertex. And by the way, you also found your axis of symmetry. The graph is decreasing and increasing. It's positive, so it's going to be an upwards U rather than a negative, which would be a downwards U. And you can plug in some values and figure out some things. Your domain on this is all real numbers. And your range is all the values greater than negative 1. Okay, so greater than or equal to negative 1. Your graph, your y values have to be bigger than that number at the right there, that point. Okay, try it again. Again, this is going to be a positive graph. So it's going to go in upwards motion. And so you're probably wondering why I put this way down here. Well, my vertex is actually really low. So it's negative 8, 2 times 2. So 2 times 2 is 4. And when you divide that, you're going to get negative 1. Nope, I take that back. 4, negative 2, so positive 2. So if I plug that in, my point is going to be 1, 2, 3, 4. It's going to be negative 7, negative 9, negative 7, negative 1. And remember, this is your vertex because I just found it here. Just like it was over here, this would have been your vertex, negative 1, negative 1, because I found it right here. Okay? So that's where your graph basically is starting from, which is why I left a lot of space here. So I could actually make that happen. So 2, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way at the bottom. And then I'm going to go up a couple because it's 2 away, right? So I'm going to go up a couple. And then 4 is actually going to be at negative 1, so it's going to be all the way up here. So this is actually here because this is my y-intercept. So it's at negative 1. And you can kind of see the graph as you put these things in here. It kind of makes a pretty little U. And again, this is going to be a minimum. So the domain, again, all real numbers. And the range is going to be all the values of y greater than -9. Okay? All right. Sorry, this is turning into a long lesson, but I'm trying to give you all the little details on graphing that I can. So this right here, my y-intercept, I know it's going to be at 5. So 1, 2, 3, 4, 5. I know it's going to be there. I know this graph is going to go down, and I know it's going to be wide. So it's going to go down, and it's going to be wide. So if I look for some numbers here, I plug them in, it's going to be, oh, it's going to be kind of crazy. So I did a bunch of these already, and it's 2 is going to be 2.2, 3 is going to be 0.2, 4, -2.2, 5, -5, and then I actually did a few more than that because of the type of numbers we're working with, very tiny numbers when it comes to doing a lot of decimals. So -3, 6.2, and then I did -4, 5.8, and -5, 5. Okay, so if you're graphing this, like I said, it's very wide. And if you're looking for your vertex, it's going to be -1 over 2 times -1/5. So this becomes -2/5 over -1. Sorry, I should have, well, that's okay. But let's actually get rid of that negative and make it positive right there, because I know my result's going to be negative. So when you do it, when you have a fraction like this at the bottom, flip it. So you're good to go. So it's -5/2 or 2.5. So at 2.5, that's my vertex. And if I plug that back in, I get -1/5 times 2.5 squared minus 2.5 plus 5, and you would get where that vertex is exactly. And it's somewhere around 3, right about there. And you can plug in some of the other numbers too. So like you have -5 or 5, -5, which is here. You have -5, 1, 2, 3, 4, 5, and that one's at 5. So you can see how wide this graph gets. And then 4 is at like -2.2 all the way down here. 3 is kind of right here, and 2 would be right about here. And you can see the graph is very wide. And this is a maximum right here. Okay, I didn't find the exact value, I just wanted to graph it. And I also want to work with the domain and range here, so I actually do need to figure this out. So the domain is all real numbers, and the range is going to be y is less than or equal to 6.2. Okie dokie. All right. So we're just going to look at these and we're going to determine whether it has a maximum or minimum, and we're going to find the value of that max and min. So basically when I say find the value of the maximum or the minimum, I'm talking about finding the vertex. So I've done some of these, and I'm actually just going to, I've done these ahead of time. I'm going to leave it on here for you to look at instead of just repeating a bunch of stuff that I've already done, since this video is already almost at 20 minutes. And I'm sure you're probably done listening to me. So pause the video and take a look at the ones I've already done and write them down if you'd like to. You're just using your -b over 2a, plugging it back in, and then finding your point and determining whether it's a minimum value or a maximum value. Remember, it's minimum if this is positive, and it's maximum if this is negative. All right, guys, that's been 20 minutes. more than enough time. If you have any questions, please let me know.